Good day everybody, we are expected to integrate this. Foremost, we will utilize this equivalent identity which states as cot theta to be as 1 over tan theta. So this is equal to square root of tan theta plus 1 over root of tan theta times d theta. You take the LCM as root of tan theta. This will give you root of tan theta times root of tan theta, that will be tan theta, positive 1 times d theta. Okay. Now the next step that you need to do is, probably I'll use this space here. Let me take tan theta to be equal to some t squared, so that we will be able to handle the square root here. So differential of tan theta is secant square theta d theta. Differentiation of t squared is 2 times t dt. So d theta is 2 times t dt divided by secant square theta. But we know secant square theta minus tan square theta is equal to 1, and secant square theta is equal to 1 positive tan square theta. So this can be utilized in place of secant square theta. So therefore d theta is equal to 2 times t dt divided by 1 positive tan square theta. But tan theta is t squared. So d theta will be equal to 2t over 1 positive. In place of tan theta you substitute t squared, that will become t raised to the power of 4 times dt. So coming back over here, integral 1 positive t squared divided by root of t squared. In place of d theta I have got 2 times t dt divided by 1 positive t raised to the power of 4. Now square root of t squared and a t gets cancelled. You have a 2 there, take the 2 out. So you have 1 positive t squared divided by 1 positive t raised to the power of 4 times dt. Now take t squared out. So this is going to give you t squared of 1 over t squared positive 1 times dt divided by t squared goes out. So it's going to be 1 over t squared positive t squared. This is what you are getting. Now t squared can be cancelled. So this is going to be equal to 2 times of integral 1 positive 1 over t squared. I'm going to write it in this fashion: 1 positive 1 over t squared times dt divided by, now this is t squared positive 1 over t squared. Now we have to make a proper substitution. So for that I want to have the following. So this is equal to 1 positive 1 over t squared divided by, can I write this as t negative 1 over t, the whole squared? If I were to expand it, I get t squared plus 1 over t squared, followed by a negative 2, but I need to get rid of a negative 2, so I add a positive 2 there. Okay, I hope you're following me. So this is the perfect square expansion times dt. Okay, fair enough. So let me move to the next space. So what do we have? We got 2 times integral 1 positive 1 over t squared times t negative 1 over t whole squared positive 2, right? So let me check. T negative 1 over t whole squared positive. Okay, now we will have to make the following substitution. So what I wish to do is, I would like to let t negative 1 over t be equal to sum u. I differentiate this, I get 1. I differentiate this, I get 1 over t squared times the dt is equal to du. So this is equal to 2 times integral, in place of 1 positive 1 over t dt you substitute du. In place of t negative 1 over 1 positive t you substitute u as a square there. You have 2 there. I'm going to write it as a root of 2 squared. Now this is very much likened to the formula integral dx over x squared positive a squared, which is nothing but 1 over a tan inverse of x over a plus c. So utilizing this formula, I get 2 times 1 over root 2 times tan inverse of x over a, u over root 2. But what is my u? My u is t negative 1 over t. So substitute that. So it's going to be 2 over root of 2 tan inverse of t negative 1 over t divided by root of 2. Now what is my t? I don't have a t, but I have a t squared, so I can extract that value. So this is 2 over root of 2 tan inverse of, take the LCM, this is t squared negative 1 divided by t times root of 2. So this is what we've got. Now we have this substitution, t squared is equal to tan theta. Since t squared is equal to tan theta, t is equal to root of tan theta. So this is 2 over root of 2 tan inverse of tan theta minus 1 divided by root of tan theta times root of 2. Now this can be further rewritten as, now you should know that 2 can also be rewritten as root of 2 times root of 2. So you have a root of 2 times root of 2 divided by root of 2 times the tan inverse of tan theta negative 1. I can rewrite this as 2 times tan theta root of the whole component taken to be as a square root embedded in. So root of 2 gets cancelled. So you can rewrite the component in this following fashion. So this is equal to root of 2 times tan inverse of now you see here you have a root of 2. Now you can very well stop here. There is no harm in stopping here, but sometimes it becomes necessary to get rid of this root of tan theta. So for that, what I wish to do is I would like to rewrite this tan theta as tan theta root of tan theta times root of tan theta negative 1, okay, divided by root of 2 times tan theta. Okay, now having got that, I need to go to the next page. Now let me, because sometimes it becomes imperative that we get rid of that. So now this is equal to root of 2 tan inverse of, now you take one of the root of tan theta out. If I take that, I get a root of tan theta. Okay, this is negative 1, so it's going to be 1 over root of tan theta, right? Now there is root of 2 tan theta there, so substitute the root of 2 times root of tan theta. Okay, now root of tan theta gets cancelled. As I mentioned to you, 1 over tan theta is cot theta, so 1 over root of tan theta will become root of cot theta. So this is equal to root of 2 times tan inverse of root of tan theta negative root of cot theta, okay, plus arbitrary constancy. You will have to reach this point. Okay, so having given you this, okay, one more thing. I will have to get rid of, I will have to move this root of 2 inside, because if I were to take the 1 over root of tan theta as root of cot theta, fair enough, we are getting root of tan theta and a negative root of cot theta. Okay, that settles. Now root of tan theta gets cancelled, but we have a pre-multiple of root of 2. Now what I need to do is, either you can just retain it as a pre-multiple of 1 over root 2, or you can push this root of 2 inside. Okay, so this will complete the solution for this question. I hope you enjoyed this. Please like, share and subscribe. Thank you.